Hello everyone, welcome back to my YouTube channel Unfog with Dr. ATAHAR PARVEEN. Here are the most awaited lectures on optics based on HSTR, KREIS and TET syllabus. This lecture will also be useful to Karnataka TET and Kendriya Vidyalaya school aspirants. Friends, if you have attended my GPSTR class of optics, then you will know that the portion or the syllabus which was allocated for GPSTR was this. Now they have included more syllabus in that GPSTR syllabus for HSTR, and of course KREIS they have given just one word, optics. So it is a general syllabus. Until and unless the KREIS notification comes, we cannot say what exactly does that optics includes. So the next syllabus which is included in HSTR is this. Now what I am going to do is, I am going to make 3 to 4 lectures. I really don't know, maybe 3 to 4 or maybe 4 to 5 lectures also, because for GPSTR we did not go into much deeper because it was an easy exam. For KREIS and HSTR we need to go into much depth for the basic topics, not the advanced level topics. We don't need to go into deeper for the advanced level topics, but for basic topics we need to go into deeper. Okay. And also if you have attended one of my video wherein I have discussed the weightage of the chapters for physics syllabus for HSTR and KREIS, there if you have not attended that video, so please go and watch. I will give the link in the description. There we concluded that optics is the chapter with maximum questions in the question paper. Around 5 questions are asked from optics in previous year question papers. So we have to expect the same type of questions. Maybe 5 to 6 questions can be asked from optics this year also, both in HSTR and KREIS. Okay. So to start with, I am discussing about properties of light, mirrors, reflection, then different types of mirrors, image formation, mirror formula and their uses in this lecture. Why I am taking only so much topic means, in this lecture I am going to discuss around 30 MCQs, 30 multiple choice questions. Okay, so that should be more than enough for you all. Any one question which comes from the topic will be from those 30 questions only. So please do watch this video lecture carefully, make notes and also give attention towards the MCQs which I am solving. Those MCQs they could be very basic questions also. They could be little bit tougher questions also. Okay, I have kept in mind everything, the basic level also and the sort of difficulty level also, because this topic is only basic, right? This topic we started learning about mirrors and reflection right from our high school. We have read it till our graduation, isn't it? So this is a very basic topic, we cannot take lightly. So I am discussing around 30 questions in this lecture. Okay, without wasting our time, let's start with what is light. Light is a form of energy that enables us to see things. And how are we able to see things? When light starts from a source and bounces off objects, our eyes perceive the light and our brain processes the signal and eventually it allows our eyes to see the things. And light has few properties, right? They are the well-known properties. The first is that light travels in a straight line. This is also known as the rectilinear property of the light. Remember in our one of the previous classes of chapter sound, we told that the speed of sound is 340 meters per second. Now make a point that light travels at speed of 3 into 10 to the power 8 meters per second, which is very much faster than that of sound. This can be a MCQ question. Next is light can be reflected. There is a possibility of refraction of light, dispersion of light, diffraction of light, polarization and interference of light. In GPSTR syllabus we had only reflection, refraction, dispersion, but here in HSTR and KREIS syllabus we need to know all the 5 properties of light, 5 to 6 properties of light. They are reflection, refraction, dispersion, diffraction, polarization and interference. Now what is reflection? Light starts from a source and bounces off objects, or you can also say that light starts from a source and it is traveling in one medium, then it bounces off when it is incident on the surface of another medium. This is known as reflection. Here you can see that this is a plane, some plane slab or something, some solid it is, but it is plane. Okay. Now one light is initially falling on it and then it is getting reflected. Now the light ray which is initially falling is known as incident ray, and the light ray which is getting reflected is known as reflected ray. It is bouncing back here, right? The incident ray, after it touches the surface of this plane, it bounces back. This is known as reflected ray. There is one more line which we call as normal. We draw it perpendicular to this plane surface. This is the normal to the surface, and this is a very important line. This is an imaginary line, but it is very important because we are finding the angle of the incident ray with respect to the normal, and that angle is known as incident angle, and the angle which is made by the reflected ray with respect to the normal to the surface is known as reflected angle. Okay. Now whatever this reflection happens, it is based on two laws. They are known as laws of reflection. The first law is that the angle of incidence equals the angle of reflection. Always, whenever reflection happens, it follows this law that the angle of incidence, here theta I, is equal to theta r. The second law states that the incident ray, the reflected ray, and the normal to the surface, all three of them lie on the same plane. And the two rays, the incident ray and the reflected ray, they are on opposite sides of this normal. Okay, these two are the laws of reflection. One more thing which I have to discuss here is the glancing angle. This is the angle between the incident ray made with the plane of the mirror. You denote it by G. Okay, small g. So along with angle of incidence and angle of reflection, you should know what is glancing angle. Okay. After knowing what is angle of incidence, angle of reflection and glancing angle, we should also know what we call it as angle of deviation. Angle of deviation means it is the angle between the incident ray and the reflected ray, or the incident ray and the deviated ray. Okay, so this angle of deviation we denote it by Greek letter delta, and this will be equal to 180 minus of angle of incidence plus angle of reflection, or because we know that angle of incidence is equal to angle of reflection, so I can say that I is equal to R. So in place of R, if I write I only, then angle of deviation delta will be equal to 180 minus 2i. Or if I assume that this angle of incidence and angle of reflection is nothing but one angle which I give the same name as theta, then angle of deviation delta will be equal to 180 minus 2 theta. Why we are taking 180 here in angle of deviation? Because some of the angles constituted in a straight line is 180. So angle of deviation will be equal to 180 minus 2 theta. Okay, so questions can be asked based on glancing angle, based on angle of deviation, or based on laws of reflection. We need to know all these points thoroughly, keeping in mind the HSTR and KREIS difficulty level of the questions. Okay. What happens in a plane mirror? Imagine if you are standing in front of a mirror. Here I have kept a candle. Imagine that you are standing here in front of a mirror. Then you can see your image, right? You can see your image in the mirror. Now what will be the properties of this image? See, now because I am giving an introduction about this chapter, I am going in detail. Now further I will assume that you know all these things. So that's why please watch it carefully. Okay. So when we are talking about the properties of image in a plane mirror, we are telling about these four properties. What are these four properties of the image? Formed. The first is the virtual and erect image is formed. What do you mean by virtual? Virtual is that something which you cannot touch, or which you will just have to imagine. You cannot touch. Can you touch the image in the mirror? You cannot touch, isn't it? Actually, that image which is formed here in the plane mirror is formed with the light rays which appear to meet. Behind the mirror, there are no light rays, right? There are no light rays. We are extending these light rays which are reflected. These are the imaginary extended lines. And then where they appear to meet, there you are finding the image. That's why we call this type of image which you cannot touch, or which is formed by the light rays which are appearing to meet, which are not actually meeting. They are the imaginary lines. Okay, that type of image is known as virtual image. So in a plane mirror, there is a virtual image and it is erect. Erect means straight. This is the first property of the image formed in the plane mirror. What is the second property? How does the image look? The image looks same as the object. The size of the image is same as the object. There is no change in the size of the image. Third is that the image is formed is as far behind the mirror as the object is in front of it. You must have noticed, if you take something very near to the mirror, then the image appears to be very far in the mirror. So that is the property of the image formed in the plane mirror. And the last and the most important property of the image formed is that it is laterally inverted. What do you mean by laterally inverted? For example, if you are taking a poster written as no in front of the mirror, then your no looks like this. So this no looks laterally inverted in the image. So these are the properties of image formed in the plane mirror. Okay, same thing we are going to do with the spherical mirrors and lenses also. There are three things, right? Even in your syllabus you can see. I am taking an example of the plane mirror just to make things simple and make you understand, so that in the further difficult stages things become easier for you. So I am talking about mirror now. Same things like the properties of the image which I have showed here, same things we are going to describe for the spherical mirror as well. Okay, so let's proceed. Here I would like to mention one more important point which involves the number of images formed in a plane mirror. If there are two plane mirrors and if you have to find the number of images, then if you know the angle between those two plane mirrors, then you can find the number of images formed. The angle between those two plane mirrors is angle theta here. Okay, and number of images you can denote it by n. We shall solve numericals based on this formula, then you can understand what I am actually trying to tell you. For instance, just remember that number of images n is equal to 360 upon theta minus 1, where theta is the angle between the two plane mirrors. Okay, the angle with which the two plane mirrors are inclined, that is our theta. Now based on angle of incidence, this type of a question can be asked. The angle of incidence of a ray falling on a plane mirror is 45 degree. The deviation produced by the plane mirror is, see here, theta. The theta is given as 45 degree. We know that the angle of deviation is equal to 180 minus 2 theta, isn't it? Here angle of incidence is given, that means theta is given, which is equal to 45 degree. We know that the angle of deviation produced by the plane mirror is delta, which is equal to 180 minus 2 theta. Just we can substitute the values here. Put theta is equal to 45 degree. Then angle of deviation delta will be equal to 180 minus 2 into 45. 2 into 45 is 90. So angle of deviation will be equal to 90 degree. Next expected question is, a ray of light is reflected at an angle of 15 degree. If the angle of incidence doubled, then the angle of reflection will be. Here what they are telling, they have given you the angle of reflection, that is 15 degree. Then they are telling that angle of incidence is doubled. Now one thing we know, that angle of incidence is equal to angle of reflection, right? So if angle of incidence is doubled, then angle of reflection will be equal to 2i in place of I, isn't it? We know that angle of reflection is equal to angle of incidence. Now angle of incidence is doubled. So angle of reflection will become 2 times angle of incidence. With that we can find angle of reflection, right? So here the angle given is 15 degree. So reflected ray will be at an angle 2 times that 15 degree, or the answer will be 30 degree. Okay. Now let's proceed with what is reflection. First of all, reflection, it happens in a highly polished surface. Okay, that polished surface could be a mirror. This mirror, it reflects most of the light falling on it. Okay, because they are curved in their shape, so we call them as spherical mirrors. Then that curve, because of that curve, there are two surfaces, right? One is inward, the other is outward. Inward means it is made curved inside. Outward means it is bulged outside. First of all, I would like to give you this trick of this spoons. See, when you are taking some sweet with a spoon, the portion in which the sweet is occupied, this portion is curved inwards, right? It is curved inwards. So this is the reflecting surface for a concave mirror. You can take it as an example for concave mirror. And then the other side of the spoon, which you are not using, which is the bulged side, that is the reflective surface. Then this is the example of a convex mirror. Okay. So this is a trick I have made for you to remember what is concave mirror and convex mirror. For example, this is a concave mirror. Here outside portion is polished. Here it is gray and here it is black lines are there. It is polished. So light falls in the inside surface. So we call it as a reflective surface. So in a concave mirror, the image formed of the object is enlarged. Similarly, in a convex mirror, the polished surface is inside. The reflective surface is outside. Here image formed is smaller than that of the object. The word we used is diminished. Smaller means diminished. Okay. Bigger means we use the word enlarged. Okay. Sometimes we also use the word highly enlarged. Okay. I hope that I am clear with what are concave and convex mirror. So simple thing which you have to remember is wherever there is a polished surface, their light does not fall. That is not a reflective surface. The other part is the reflective surface. Spoon is the best example, I think. Okay. Now, there are some parts of these mirrors. There are certain parameters of the mirrors which we need to know. Okay. Until and unless we understand them, we cannot proceed. They are very important but still very basic. Okay. So, let's have a look at them. Here I have made two mirrors. This is a concave mirror and this is a convex mirror. Now imagine that there is a circle. Actually these mirrors, they look like half circles, right? Complete these circles. Imagine that these are complete circles. Now here this is reflective surface. This is a concave mirror. Now this is reflective surface here, the outside one. This is a convex mirror. And then this is known as the linear aperture, whatever the space is there with the mirror. Now, the center on the surface of the mirror is known as pole and the center of that imaginary circle is known as center of curvature, and then the line which crosses through the center of curvature is known as principal axis, and there is a point between the pole of the mirror and the center of curvature. This is known as principal focus, and the distance between the pole and the principal focus is known as focal length. Okay. And the distance between the center of curvature and the pole of the mirror is known as radius of curvature. Okay. These two are very important things. Radius of curvature, it is simply like the radius of the imaginary circle. When see the center of curvature is the center of the circle. And focal length is half of the radius of curvature. So what will be the actual value of focal length? It will be equal to r upon 2. If center of curvature is denoted by capital R, then focal length of the spherical mirror will be equal to r upon 2. So this is a very important point here to note down. They can ask you one question based on this. I am expecting this type of a question this time. For example, there could be a 1 mark question. What is the relation between focal length and radius of curvature r of a curve mirror? So what will be the right option? R upon 2. Okay. There could be one more question, for example, like this. Find the focal length of a convex mirror whose radius of curvature is 32 centimeter. They have given you the radius of curvature. You have to find the focal length. Now you know that the focal length is equal to r upon 2. Just substitute and then you get the value. Okay, it is 32 upon 2, which is 16 centimeter. Now there are certain rules so as to understand how the light falls and gets reflected on two mirrors, the concave mirror and the convex mirror. The first rule is that if this light ray, it is parallel to principal axis, then after reflection, it will pass through principal focus. And in convex mirror, if it is parallel to principal axis, then after reflection, it will diverge. Okay, it is getting diverged from the principal focus. When it is getting diverged, you draw these dotted lines, the imaginary lines. You can see that it meets at the principal focus. Same thing is happening even in concave also and in convex also. When the ray of light is parallel to principal axis, then after reflection, it is meeting at the principal focus. Only thing here difference is that here real light will meet at the principal focus in concave mirror. In convex mirror, the light diverges, then we draw an imaginary line which meets at the focus. Okay. Then the second rule is that if the ray of light is passing through principal focus, directly if it is going through the principal focus for a concave mirror or for a convex mirror, after reflection, the reflected rays will be parallel to principal axis. Here in concave mirror, it is parallel, here you can see. And here in convex mirror, now this is the incident ray, it gets reflected like this. So it is parallel. And the third rule is that if a light ray is passing through center of curvature for a concave mirror or directed in the direction of center of curvature for a convex mirror, because it is really not happening here, right? We will have to draw the imaginary line. Then after reflection, in both the cases, the light gets reflected back along the same path, in which it has come. You can see here in concave mirror it comes like this and then it reflects back also in the same direction. In convex mirror also it is incident like this, then it's reflecting back like this only. Here we are drawing the imaginary line which is meeting till up here, till the center of curvature. Okay. So these are the three rules which you have to keep in mind. The first is that if the incident ray is parallel, then the reflected ray will be going through principal focus. Second rule is that if the incident ray is passing through the principal focus, then the reflected ray will be parallel. You can just observe the first case and the second case, they are opposite. Okay, they are opposite. Here incident ray is parallel, so the reflected ray is going through focus. Here incident ray is going through focus, so reflected ray will be parallel. This is what will happen in the mirrors. In this entire class, I am going to make relations in this type only. It will be opposite every time. I will tell you as and when possible, okay? And in the third case, it is simple. When the light passes through center of curvature, the reflected ray is also going through the center of curvature. Here we have noticed that all light rays reflected by concave mirror converges at its focus. And in convex mirror, what is happening? There is a divergence. A convex mirror is called a divergent mirror because it diverges a parallel beam of light incident on it. So a concave mirror is called as a converging mirror and a convex mirror is called as a diverging mirror. Okay. So now let us start with more details on concave mirror. So here I have made the animation to make you understand how the light converges in a concave mirror. And what will be the properties of the image formed? The image is real and it is inverted. But it is not seen here because it is diminished. It has become so smaller like a point at the principal focus that you cannot see it. Because of this speciality of converging the light, the concave mirrors have some good applications. These are the applications. They are used in torches, searchlights and vehicle headlights so that you have a powerful parallel beam of lights. Also they are used in shaving glasses and dentists also use them because if the object is smaller, then the image formed is bigger here. If the object is bigger, then the image formed is smaller here. Okay, and the distance between the object and the mirror also plays very important role. For example, here you can see that our object is at infinity. So it is very, very far. So the image formed is diminished and it is formed at the principal focus. Now, how are the images formed? If the object is at different positions, we will try to understand it. Here, if the object is at infinity, as I told you now, if the object is at infinity, then the position of the image formed is at focus, the principal focus. It is highly diminished. That means it has become so smaller to like the point size that we can't see it. Okay. And it will be real and inverted. Here, the speciality of the concave mirror is that the image is always real and inverted because the image is formed in front of the mirror. Whenever the image is formed in front of the mirror, always the image will be real. If it is formed behind the mirror, like in the plane mirror, then only it will be virtual. I will give you a trick also to understand this, to remember this, okay? First thing is that when the object is at infinity, here you can see the object is at infinity, the image is formed at principal focus. And if the object is beyond the center of curvature, here also it was beyond the center of curvature, but it was at infinity, it was very, very far. If the object is nearby and it is beyond the center of curvature, then you can see that the image formed is between the center of curvature and the focus, and it is inverted. Means ulta. You see it in the opposite way. It is inverted. It is diminished. The size is diminished. Now, third case is that when the object is at the center of curvature, then image also will be formed at the center of curvature and it will be of the same size. And in fourth case, the object is between the center of curvature and the focus. The blue color line is the object here. The black color line is the image here. The image is formed beyond the center of curvature. It is inverted and it is big. It is enlarged. And in fifth scenario, if the object is at focus, then the rays go from the object, it falls on the mirror, then it reflects back, it comes through focus and the image is formed somewhere at infinity and it will be very highly enlarged. You can't see it. It will be highly enlarged, but you can't see it because it is formed at infinity. And in the last case, if the object is between the pole of the mirror and the focus, then only you are going to see an virtual image. That is, the image is formed behind the mirror and it will be enlarged when compared to the object. Okay. I hope you have not confused with what I have told till now. But still, if you are confused, I have a trick for you to remember. Just to relate the center of curvature and the focus. Just to remember the first scenario here. What is the first scenario? If the object is at infinity, then the position of the image is at focus. Just remember this, okay? And the second case is that if the object is placed beyond the center of curvature, then the image is formed beyond the focus. Okay? Beyond the focus but before center of curvature. Here, beyond the focus but before center of curvature. So you can just remember beyond, if the object is beyond C, image will be beyond focus. These two things if you remember, you will know the entire table. The third is that the at C, at center of curvature, if the object is there, then the image also will be center of curvature. You can remember this easily, right? Now make it as a midpoint. Now just to see it, I am going to reverse things. Now just reverse them. What will happen if the object is between F and C? Wherever the object will be there, in its opposite place image will be there. Isn't it? There in the first case, the object was beyond C, then position of image was beyond F. What will happen if the object is beyond F? Position of image will be beyond C. Same thing you can relate here again. Now in first case, image was at focus, right? Now what will happen if object will be at focus? Yes, image will be at infinity. Just two things you have to reverse. That's it, your table is complete. I hope I made you understand this trick. And the last case is little bit different. It is like in a plane mirror. Okay, here only, see, you can see in all other cases, the nature of the image is real and inverted. Only in this case, wherein the object is between pole and the focus, then only the image is formed behind the mirror. If the image is found behind the mirror, means it will be enlarged and it will be virtual and direct. Okay. I hope I made you understand. In this lecture only I am going in so much detail. In the next lecture, I am not going to go in so much detail. So I am trying to make you understand it now only. Okay, this is the case of a concave mirror. Now let's move on to what about the convex mirror. Here you can see that the light is getting reflected from the convex mirror. That is, it is diverged here. Then we draw the imaginary lines which meet up till focus. This is happening when the object is at infinity. Then how will the image look? It is diminished, it is meeting at a focus, it is appearing to meet at a focus, and the image is behind the mirror. That's why it will be virtual, it will be erect, and because it is at a point, it is diminished. Okay, and because of this property of a convex mirror, that it diverges light, it also has few applications, such as they are used in this street lights. They are used as in a rear view mirror, because they always give an erect, though it is diminished image, they give an erect image. Also, they give you wider field of view and enable the driver to view much larger area. So these can be your 2 marks questions, the applications of concave and convex mirrors. So please do make notes on this. Okay. Now more details on a convex mirror. How is the image formed? See, it is very simple for a convex mirror. If the object is at infinity, then the image is formed at principal focus F. Okay, because the rays appear to meet here. And if the image is between the pole of the mirror and some infinity, then the image is formed between the pole of the mirror and the focus, and it is diminished. And remember, the speciality of the convex mirror is that every time you will find only virtual and erect image, like the last situation in the concave mirror. There the object was between the pole and the focus. Here the object will be between the infinity and the pole. Okay, and these will be the size of the images. In first case, if the object is at infinity, the size of the image will be highly diminished. Highly diminished, it will be in the point size, you can't see it. And here it will be diminished. We cannot use the word highly because you can see it here. Okay, now we are talking about the situations wherein how the light gets reflected and where is the image formed depending on where the object is kept. But we will have to use certain sign conventions. We will have to know where to use plus and where to use minus in spherical mirrors. For this, there is a simple funda, the simple strategy. Just to treat this entire thing, the mirror setup, like a coordinate system. Okay, this mirror Mn, you put it in the place of y dash, the y axis, and the principal axis x dash, you put it in the place of x axis. Okay, and treat the pole as the origin of this coordinate system. I have made a simple notes for you all. Please note it down or take a screenshot and try to remember this. This is very simple. Don't get worried with the text I have written here. The first thing is, assume that the pole P is at the origin. And the second is that assume that the principal axis is the x-axis. Now you treat it as a coordinate system. You know where to use plus and where to use minus, right? In the first quadrant, both x-axis and y-axis are plus. In second quadrant, y-axis is plus and x-axis is negative. In third quadrant, both x and y-axis are negative. And in fourth quadrant, x-axis is positive and y-axis is negative. Same thing you have to follow here also. What you do first, the object, first of all, it is always placed in the left of the mirror, right? Till now you have seen, even in both the cases, in concave and convex mirror, in both cases, the object is always placed to the left of the mirror. Light falls from this object on the mirror, isn't it? Now, one more thing is that all the distances parallel to this principal axis, they will be measured from pole. Like you measure it from origin. If there is one line like this here, you measure it like this from the pole. Okay, now coming to the 4 fundas. What is it? All distances measured to the right of the origin, the x-axis, this should be positive. To the left should be negative. Here if you draw this perpendicular, the y-axis, this thing, this should be positive above origin and negative below the origin. That's all. So just remember these sign conventions. It will be very helpful for you to solve the numericals. Now very important point is that your focal length of concave mirror will always be negative, because the principal focus, the point, it falls on the second quadrant, on the principal axis. here, the second quadrant on the principal axis. So this is always going to be negative. And conversely, for the convex mirror, this is a imaginary lines meet up till one focus, right? That will be on the right hand side, the right of the origin, right of the pole. So the focal length for a convex mirror will always be positive. So just keep these 2 points in your mind. This is going to help you very much. Okay. Focal length of a concave mirror will be negative. Focal length of a convex mirror will be positive. Now let us know 3 things. One is focal length, which we already know. Other 2 things are the distance of the object from the pole and the distance of the image from the pole. The distance of the object from the pole is known as object distance. Its symbol is small u. You have to remember this symbol. This is very important. Symbol is small u. Distance of image from the pole of the mirror is known as image distance and the symbol is small v. Okay. Now there is a formula relating to these 3 parameters u, v and f. This is known as mirror formula. And it says that 1 upon v plus 1 upon u is equal to 1 upon f. Where v is the image distance, u is the object distance and f is the focal length of the mirror. There is one more thing which we have to know, which is known as magnification. Now what is magnification means? See, from the original size of the object, how much bigger is the image seen? The image which is seen, how much more bigger it is than the original size of the object is known as magnification. How do you find it? You see the height of the image divided by height of the object. How much bigger it is? You do same thing in maths also, right? This you can also relate with the object and image distance, which is equal to minus v by u. Okay? Minus v by u. Remember, minus v by u. Why I am using minus here means there is a reason. Negative sign I will use if the image is real. Positive sign I will use if the image is virtual. Okay. Magnification of the image will be negative if the image is real. This happens in concave, right? Except in one situation. And positive sign for the magnification means image is virtual. This happens in convex mirror, right? And in the one last situation in the concave mirror. Okay. Now the height of the image should be taken as positive for virtual images, negative for real images. That you have to remember. Now I am going to solve around 30 questions based on what all we have discussed till now. If you have not watched the video till now thoroughly, or if you have forwarded it or if you have skipped it, please go back and watch the entire lecture, or else you won't be able to understand these questions. You will not be able to solve these questions along with me. Okay. These questions, they include the simplest questions, the easiest questions also, and the tougher questions also. But all are based on what all I have discussed till now. Okay. So these are all the expected questions which can come in HSTR and KREIS. Believe me, more than this is not required. Okay. This is more than enough for this portion. Okay, the first question expected is, actually I have done already 3 to 4 questions. Okay, I have done them based on focal length and based on number of images found. These are the other questions which could be asked. Okay, the question is, mirror having a curved reflecting surface are called as. So what are the mirrors having the curved reflecting surface called as? It's a very simple question, right? They are spherical mirrors. I told you, right? They can ask you as simple questions also. They can ask you as tougher questions also. I am touching all type of questions in this lecture. Next question. Spherical mirror with reflecting surface curved inwards is called. Of course, you remember that spoon trick. It is concave mirror. Next question. The imaginary line passing through the center of curvature and pole of a spherical mirror is called. It is called principal axis. The focal length is equal to half of the dash. Remember, we have done this also. It is half of the radius of curvature. Next question. Pole lies on the surface of. Where does the pole lie? Remember, it lies on the surface of the spherical mirror. Spherical mirror with reflecting surface curved outwards is called. Curved inwards was concave. Remember the spoon? Curved outside will be convex mirror. The center of a sphere of which the reflecting surface of a spherical mirror is a part is called. Of course, it is called center of curvature. The angle made by the incident ray with the reflecting surface or interface is called as, glancing angle. Remember, we have denoted it by G, the glancing angle. It is the angle made by the incident ray with the reflecting surface or the interface of the mirror. The distance from the plane to the focus is called, focal length. This is very important point. The distance from the pole to the focus is called focal length. A girl stands at a distance 30 cm from the mirror. She is able to see her erect image but of 1/5 height of actual height the mirror will be. So which is the mirror which shows you the diminished images? So small and erect image is formed only by convex mirror. Actually plane mirror, it forms images equal to object, and concave mirror, it forms images bigger than object. While convex mirror, it forms images smaller than the object. So answer should be convex mirror. Next question, image behind the mirror is, what is the image behind the mirror? It is always a virtual image. A real image is always, what is a real image characteristic? It is always erect, upright and inverted. So all of the above will be the right answer. Next question, convex mirrors produce, what types of images does convex mirrors produce? They produce only virtual images. Next, these two questions are based on mirror formula. First question is, the correct expression which indicates the relation between focal length, image distance and object distance for spherical mirror is, it should be the mirror formula, right? The mirror formula is 1 upon f is equal to 1 upon u plus 1 upon v. So 1 upon f is equal to 1 upon u plus 1 upon v. Option A should be the right answer. Next question, if the distance of object from concave mirror is 4 times the focal length, then position of image will be obtained at. So they are telling that the distance of the object from concave mirror, it is 4 times the focal length. You have to find v. They have given you u. They have given that u is equal to 4 times f. Now you have to find v. It is very simple, right? Remember, for concave mirror, focal length is negative, object distance will be negative, isn't it? Why? Because of the Cartesian coordinate trick. You have watched this. Remember, the focal length and the object distance are always negative for concave mirror according to our coordinate axis tricks. Okay, you have to remember that. For convex mirror, object distance will not be negative. Remember, for concave mirror, focal length will be negative and distance between the object and the mirror will also be negative because of our coordinate axis funda. You have to remember that. Now apply the mirror formula and substitute the values. 1 by f is equal to 1 by u plus 1 by v. Substitute the values. You will ultimately get that 1 by v is equal to minus 3 by 4f. If you take the LCM of 4f and f, you get this 3f's. In the numerator. Now if you take the LCM of this 4f and f, then you get the LCM to be equal to 4f square. So ultimately you will cancel 1f from numerator and 1f from denominator, and you will get 1 by v is equal to minus 3 by 4f, or ultimately v will be equal to minus 4f by 3. Just you have to substitute the values here. Here option C will be the right answer. Don't worry, we are going to solve many numericals based on all this. You will thoroughly understand everything, and just you practice along with me. That is more than enough. Next question. Focal length of convex mirror is 20 cm. Produces image at distance of 10 cm from pole behind the mirror. Object distance should be. Here what all they have given? They have given you the focal length of convex mirror. And remember, convex mirror means focal length should be positive. Concave mirror means focal length should be negative. So focal length is 20 cm and then image distance is 10 cm. Now you just substitute the values, you will get the object distance easily. Use the mirror formula. 1 by f is equal to 1 by u plus 1 by v. Remember, focal length and image distance both will be positive for convex mirror. So just substitute the values. You will get the object distance will be equal to minus 20 cm, which is right because object distance for convex mirror will be negative. So option A will be the right answer. Okay. Next question. Using concave mirror of focal length 25 cm, size of object is doubled that its original. Then which of the following is correct relation? They have given you concave mirror, so focal length will be negative. Size of the object means it is nothing but magnification. Remember, wherever you get the size of the object, the word size of the object means it is always magnification. Okay, size of the object or size of the image. If they are talking about size means they are talking about magnification. This magnification is equal to minus v by u, right, for concave mirror. Now they are telling that it is doubled, so magnification will become 2. That you write here, 2 will be equal to minus v by u. You get the relation between u and v when you know the magnification, isn't it? So v will be equal to 2u here. Actually v will be equal to minus 2u here, but in the options they have not given the minus sign. That's why we are writing v is equal to 2u. Option C is the right answer. Next question. Find the number of images formed by two mutually perpendicular mirrors. Remember our formula? 360 upon theta minus 1. But here they have not given you theta directly. They are telling that the two mirrors, they are perpendicular to each other. Mutually perpendicular to each other. That means the mirrors are inclined at angle theta, which is equal to 90 degree. So just substitute theta is equal to 90. You get n is equal to 3. Option A will be the right answer. Next question. The image formed by a convex mirror is of the size of 1/3 the size of the object. How are u and v related? Now they have given this condition that magnification is equal to 1 by 3. 1/3, right? 1/3. If they give only 3, then magnification will be only 3. They are telling 1/3. That means 1 by 3. Magnification will be 1 by 3. Then for convex mirror, you don't have negative sign for convex mirror, right? For concave mirror, you have minus v by u. For convex mirror, you have v by u. Now just substitute the value, you get u is equal to 3v. Now whatever if the options are given, this u is equal to 3v will be there in the options. That will be the right answer. Okay. Next question. A concave mirror forms a virtual image of size twice that of the object placed at a distance 5 cm from it. They are telling it is twice that of the object, means magnification will be 2. And then it is a concave mirror, so object distance will be negative and it is given as minus 5 cm. Now you have to find two things, position of the image and focal length of the mirror. First you find the position of the image using this magnification formula. It is simple, right? It will be equal to 2. So 2 will be equal to minus v by u. Then you find the value of v. Now you have u, you have v. You can easily find f, right? Using the mirror formula, focal length 1 by f is equal to 1 by v plus 1 by u. Substitute the values. And then simplify, you get f is equal to 10 cm. Okay. In the options, they may give like that. Magnification and focal length values they'll give and they'll put comma. Those values will be different. You have to choose the right answer. Okay. Next question. Concave mirror of focal length 40 cm forms image of object 2 times its size. Object should be placed at. Now what they are doing, they are giving you the focal length which is 40 cm and then they are telling that the image magnification is 2 times. That means m is 2. With m is 2, you can find the relation between v and u, right? Till now we have done numericals like this. So you take that relation. After having that relation, use the mirror formula. What is the mirror formula? 1 by f is equal to 1 by v plus 1 by u. Substitute these values. Here focal length is 40 cm for concave, right? So it will be minus 40. So minus 1 by 40. Now in the right hand side, you take the LCM for u and 2u. You get 2u square. Now in place of v, you have to substitute 2u. Okay, in place of v, you have to substitute 2u. That 2u with the minus sign because it's a concave mirror. So in the mirror formula, ultimately you will get minus 1 by 40 is equal to minus 1 by u minus 1 by 2u. You simplify, you get the answer. U is equal to 60 cm. Okay. So option C will be the right answer. Next question. What should be the distance of image to produce magnification of 20 times if object is kept at distance of 16 cm from concave mirror? Here they have given you object distance which is minus 16 cm because they are talking about a concave mirror. Magnification, you know it, right? M is equal to minus v by u for a concave mirror. Substitute the values. You get v is equal to 320 cm. So option C will be the right answer. Next question. A concave mirror of focal length 20 cm forms an image having twice the size of the object for the virtual position of object. The position of object will be at. So what all they are telling here is focal length is minus 20 cm because it's a concave mirror and magnification is 2 because twice, right? Twice the size of the object. Now I can find the relation between V and U. After finding relation between V and U, again I'll use the mirror formula, like the last but one sum, like that only, same. Substitute and you find the value for focal length. Because it's a concave mirror, then that's why your V will be equal to minus 2U. Okay. So option C will be the right answer. Next question. A dentist uses a small dental mirror to help magnify teeth in your mouth. What type of mirror is this? Of course, it should be a concave mirror. Next question. Which of the mirrors is used as rear view mirror in vehicles? Yes, it is convex mirror. Next question. What do you call a flat mirror? We call a flat mirror as a plane mirror. Okay, so many questions I have solved for you. These two questions I am giving you as an assignment. Question number 29 and 30. I want you all to solve and let me know the answers in the comment section. Okay. I hope you all are happy with this lecture because this is the ultimate lecture for this portion. More than this, you don't need to read at all. This lecture is more than enough for so much portion of mirrors. Okay. I hope that I helped you. Please do let me know your feedback in the comment section. And also please do like, share and subscribe to my channel. And also you can join the Telegram channel. I will give the link in the description. And then if you have any doubt, you can let me know in the Telegram channel also, or you can let me know in the comment section below also. Okay friends, thank you. All the best. Bye.